Hello everyone and welcome to today's AEE member webinar. Just a couple of housekeeping things. First of all, thank you for being with us today. And as always, please post questions during the course of today's presentation in the questions section of your GoToWebinar control panel. We will be monitoring those questions throughout and asking questions periodically throughout the webinar, and there will be additional time at the end for any more Q&A that we have not answered during the webinar. As always, you will receive a follow-up email in the next couple of days that will have a link to your certificate of attendance and a link to today's recording. So without further ado, I'm going to go ahead and introduce our speaker today, which is Mr. Keith Waters, who is Industry Standards Manager with Schneider Electric USA. He is based in Lexington, Kentucky, and he is responsible for circuit protection and automation, control product standards, installation codes, and enforcement. Keith has been an employee of Schneider Electric for 34 years, working in the marketing area, engineering, price management, and has held multiple business development positions, including strategic and global account management, as well as managing several strategic segment engineering teams. Keith is also engaged in applying codes and standards addressing energy and efficiency and sustainability. Keith holds a Bachelor of Science in Electrical Engineering degree from the University of Kentucky. He is a licensed professional engineer and a certified energy manager. Keith participates in the Power and Energy Institute of Kentucky's Industry Advisory Council. He speaks frequently on various topics such as energy efficiency, sustainability, product application, and code compliance. Keith is also a member of numerous industry technical committees, and he is an NEMA, National Electrical Manufacturers Association representative to code NEC code making panel 11. Keith has also published several articles on energy management and electrical controls. So thank you, Mr. Waters, for being with us today. I will pass control over to you.
Thanks, Sharon. Well, good afternoon, everyone. I hope we're all making sure that we're keeping our distance and dealing with the challenges that we see today on a regular basis. And I wish everyone is up and well and have their health in good shape today. So what we're going to do today is discuss, kind of go through some requirements for supplying secure power with properly installed energy storage systems. So you'll see a number of times throughout the presentation where we talk about ESS, and that's the various energy storage systems. So what we're going to cover today, we'll do is Sharon's done a little bit of an introduction, talk about the objectives of this afternoon, why energy storage codes and standards are important, talk a little bit about the installation, the NEC installation requirements, that would be the National Electric Code, and then we'll talk a little bit about some other current codes and standards that affect energy storage systems, and then future energy storage system codes and standards. And we'll cover questions kind of in a couple of different ways. We'll cover them through what you write into the chat box, and then I'll also save some time at the end to have some of those additional questions that people may have that didn't make it into the chat box. So just talks a little bit about what we talked about. So I work for Schneider Electric. Sometimes people don't know who we are, or they think they know who we are. And so I like to use this slide to kind of give you a broad overview of kind of how we got to the company that we are today. With if you have not heard of Schneider, you would of course obviously heard of some of the brands and companies that we've acquired over time. And so this is just a view of some of those and how we got to this point. So Schneider is a $30 billion company. We're operate in 100 countries and have over 140,000 employees. So we are committed to sustainable development, considered one of the most sustainable corporations in the world. We are an industry leader in the Dow Jones Sustainability World and European indices. We're also in the top 10 in the world's most ethical companies. So these are things that we try to make sure that everyone understands when we're out having these types of discussions. So I just wanted to give you that a little bit of feel of Schneider. So our objectives today is to be able to identify what codes and standards guide energy storage system installations, what new codes and standards are in development for energy storage systems, and the different types of energy storage systems. And you'll be able to determine how to find statutory requirements for these installations and properly integrate energy storage systems into other parts of your electrical system safely. And then to understand the potential hazards of energy storage systems. So a lot of times people think, they think about what's going to be the application, right? We're going to use energy storage to provide base load or to help reduce our overall energy consumption within our homes or our businesses, and that's what we're using this for. And so sometimes we may not understand why the codes and standards are important. So I wanted to give you kind of a picture of that. So there is a utility, Arizona Public Service, that is driven hard to install energy storage systems into their utility grid in order to provide a couple of different supports for their customers, whether that be base load requirements or peaking requirements or whatever. So they had the installation, but they also kind of ran into an issue last year. They had a fire, April 22nd, 2019. They had a 2 megawatt lithium ion battery system explode. There were 4 first responders were hospitalized, and no final determination as to actually what caused it was available, even during all of the investigations. So to give you when you think about, all of these energy storage systems and the growth in this space, and understanding, proper installations, proper requirements around that, these are things that are expanding in that world in order for people to be able to not run into these kinds of issues. So just to give you a feel for what that looks like, that's what's left. So just to kind of set the stage for why some of the things that we're going to talk about today are important, visualize that picture. So when we think of energy storage systems, kind of in today's, lots of discussion around battery systems, lithium-ion battery systems, other types of battery systems. But there's more than just batteries when you think of energy storage, right? So you do have battery systems, you have redox flow battery systems. You also have flywheel systems. These are very, very common in data center application and large requirements for storage. You have thermal storage requirements. You'll see that even there were some presentations on the use of ice for thermal storage in last fall's AEE World conference. Then you have pumped hydroelectric storage and compressed air storage. So you have a number of types of energy storage systems. So the largest growth today, of course, is in the lithium ion area, but just I wanted to make sure you understood that's not the only way to do energy storage. So when you think of energy storage system codes and standards, so who is developing codes and standards and guidelines? And when you think of codes and standards, you're thinking of, how you build something, how you apply something, how you install something. And those are kind of where you come into these. And then you also have, once you've designed it, installed it, you have to maintain it. So kind of where does this stuff come into play? So there's a number of areas and organizations involved in this. You have Underwriters Laboratory, or UL. You have the building codes and International Code Council, or ICC. You have the National Fire Protection Association through a number of their standards. You have the National Electrical Manufacturers Association, or NEMA, is involved. And then you have other stakeholders like FM Global and DNV from the insurance perspective. So the first thing we're going to talk about is NFPA 70, or the NEC, which is the National Electric Code. So when you think in terms of electrical installations, you may or may not be aware, but the National Electric Code is a statutory requirement. So it's actually of the law of your individual states. So this is just to kind of give you a picture of the version of the National Electric Code that you may be under. If you look at as of January 1st, we actually, there was a new version published last fall to be adopted this year, the 2020 National Electric Code. It has already been adopted by Massachusetts. A number of other states are involved in reviewing and adopting. Georgia has adopted it with an implementation date of January 1st of next year. Texas has adopted beginning in September 1st of this year. Then you have states such as California that on January 1st, 2020, they adopted the 2017 NEC to join 30 other states that are currently operating under that version of the National Electric Code. And then you can see other states in varying pieces of this. The other one I'll talk about is in the yellow. You'll see 3 states have local adoption. They don't have a statewide adoption, only local adoption. And so you have Arizona, Missouri, and Mississippi. An example of how that works is, so Arizona, even though there's no statewide adoption, Phoenix, Tucson, and Tempe have adopted the 2017. So those states can be on the most current standards. They could be on some codes. They can maybe be on something that's slightly behind or something. So anyway, that's just to give you a picture of what may be going on in your state. So there were current requirements for energy storage systems and battery systems. So there's in the National Electric Code, there's been Article 480 for battery systems for a long time. But when you talk about energy storage systems, they're not just batteries, right? There's batteries, they're in enclosures, they're in control systems, there's disconnects, there's a lot of other requirements for that. So in 2017, a new article was created just for energy storage systems. So while you'll see people talk about Article 480 sometimes, that really is not where you would go to have a discussion around energy storage systems. That would be where you would go to talk about batteries. So for Article 706, which is the key energy storage system article in the National Electric Code, so it says it applies to all permanently installed systems. It operates at either 50 volts AC or 60 volts DC. It's a standalone operation, and it's interactive with one or more electric power production sources. So what that means is it could be operating with a utility system as some type of backup. It could be operating in with a generator as well. Could be photovoltaic PV systems for solar panel systems. It could be wind. There's a number of other type of interactive power production source that has to be involved because you have to be able to generate and recharge the system, whether it's batteries or whether it's some other energy storage system method, but you have to be able to charge that. And so that's why there has to be some other type of power production source.
Keith, we do have one question. Sorry to interrupt you.
No problem.
It says, where does the NRTL fit in with these code standard guidelines?
Okay, so for your NRTLs, which are those are your OSHA designated um, code development organizations, such as UL, such as ETL, TUV, and some others. So when you get into the development of the actual safety standard for building or for the production of an energy storage system, that's kind of where your NRTL or your standards development organization comes into play. We will cover the current. I'm not going to go into detail, but I will show you where there is a manufacturing standard for energy storage systems that has been developed and published, and we'll cover that a little bit later. But you will be able to see that that's where that particular NRTL and or SDO has come into play. So when we talk about energy storage systems, so we talked a little bit about this part already. We talked about the components assembled together. It's not just a battery, right? It's not just some other system that may be used, right? For a pumped hydro, you're going to use water, right? So you're talking about one or more components assembled together and capable of storing energy for use at a future time. So it can be batteries, capacitors, kinetic energy, water, right? And they can have either AC or DC output for utilization. So you may have an inverter in place or a converter in place to take advantage of those. So
okay, sorry, a couple more questions coming in here.
That's all right. I'd rather cover them as we go than just hold them all till the end. Okay.
That's okay. So the first one is, I just saw a 50-volt AC in one of the previous slides. I want to ask if it's possible to store AC in battery banks.
So the batteries themselves are DC systems, but other types of energy storage potentially could be, if you're taking mechanical energy and you're creating an activity there, then you could potentially have an AC output. When you also talk about an energy storage system, you may have batteries, but the system itself, if we go back and we think about it, it's an assembled piece of equipment. So you could have your inverter already there to take the DC from the battery system, convert it to AC, and the output of the energy storage system is AC. So you may actually so again, we're talking about an energy storage system, we're not talking about a battery system. So when we think in terms of energy storage systems, it could be different, right? It could have a straight DC output if for some reason you're operating in a DC environment. More often than not, energy storage systems are going to be operating with some type of conversion from DC to AC.
Okay, thank
Any
you.
other questions?
And then, yeah, there is another one. It says, do you have an example where energy storage was implemented as a combo at the site level, for example, peak shaving and emergency backup power?
Yeah, so where you'll see a specific example for that is if you're in an environment, and I can tell you that there's a small, it wasn't a huge system, but it was a small industrial facility here in Lexington that they were utilizing PV with the energy storage system as the optional standby system to if they lost power, they could immediately go to either the battery system or the PV, depending on whether it was day or night or whatever the method might be. So it was actually working in conjunction there. Utilities, you'll see it at grid level that utilities for maintaining voltage stabilization in areas where you might see a lot of where you get a swell, where you get a voltage drop in areas. Sometimes they'll use capacitors for that, and But what we've seen some in areas where you might have other types of wind or PV or even not at all, but they'll use it as a to keep the voltage stabilized and use it as a voltage stabilizer, which is what the APS was doing, was using it for voltage stabilization. So the first question that we got was talking about the NRTL or NRTL, which is a nationally recognized, for those that may not know what NRTL means, it's a nationally recognized testing laboratory as designated by OSHA. So the most common NRTL that we see in our day-to-day world in the US is Underwriters Laboratory for UL. If you go and look at the back of lots of products, you'll see the UL with a circle, right? You'll see a UL listed or UL recognized component. In this case, UL has went out and developed a safety standard for energy storage systems and equipment, and there is a requirement within Article 706 that energy storage systems shall be listed as a complete system. Now, when you say listed as a complete system, it doesn't mean, it means that you have to be listed to a product standard, to a safety standard. It doesn't have to be approved by UL. It could be some other NRTL that's using this particular ANSI approved standard, but it is something that that is required now if you're going to use an energy storage system.
Thank you.
So when we come through a number of these, you'll see some pictures of on a number of battery energy storage systems. Some of these, of course, are the Tesla Powerwalls and stuff are kind of easy to find pictures of and work with. So you'll see a number of these. There are others out there. So within Article 706, it does allow for multiple energy storage systems. So you could either be feeding multiple circuits or running systems in parallel. Most of the time, you're talking about separate circuits. Lots of different form, fit, and factors depending on the size of your energy storage system. You run into things like the one at the bottom left. It's similar to what we saw that Arizona Power and Light uses. On the bottom right, it's more like what you might see in an industrial environment. And then you also are seeing energy storage systems for over-the-road trucking trailers for emergencies, where they can bring them in, set them, and operate from that perspective. Just another view of this is a grid level energy storage system here. One of the requirements also within Article 706 is the ability to do a disconnect. You have to be able to disconnect all of the ungrounded conductors coming from the energy storage system. And it has to be readily accessible and in sight of the energy storage system. The point of this is to, if you have to do maintenance, if you have some type of issue with that system, you want to be able to disconnect it from the building load, to disconnect it from whatever other connection might be. There's also the opportunity to do remote disconnecting as well. So instead of using, if we go back and you look to the far right, you'll see this fusible disconnect or safety switch. It's actually off there, but it could be in the on position as well. That's disconnecting the power. You also have the ability to use the remote actuation, which would be an e-stop type button, or a button that would say when you hit it, it would trip the whatever the automatic disconnecting means might be. If you had a contactor or you had a breaker and you wanted to shunt trip the breaker or the contactor, you could do that. If you happen to be using an energy storage system for a 1 or 2 family dwelling, then that disconnecting means or its remote control shall be located at a readily accessible location on the outside of the building. The best bet's probably near the building service, just because that's where other disconnects belong. Again, one of the other things you can do is the disconnect can be integral with the energy storage system. In this case, this unit has a disconnect built into it. And then you also have the connection to the other energy sources. So if we remember earlier, I was talking about you have to have some other type of energy source, and the way to do that is what happens. So under the connection to those other energy sources, you can do loss of interactive system power. So upon loss of a primary source, an energy storage system with a utility interactive inverter would comply or shall comply with these requirements. What this allows you to do is it tells you how to do the installation to where when you lose your utility power, your energy storage system now takes over that responsibility. The other way to do it is if you have some type of unbalanced system where you have an unbalanced connection between the energy storage and your power production source, then it sends you to another section in the code to make sure it's properly connected. And then the point of connection between the energy storage system and the electric power production sources shall be in accordance with section 12. So the point of dot 8 here is just to make sure you know where to go when you're connecting to other energy sources, trying to give you as much information from an installation perspective. So the other things that you run into is you have requirements for locations, right? You need to make sure you have wherever you are, you have proper ventilation, you have proper guarding of any type of live parts. So somebody, if they open a door, they're not going to immediately be accessible to live parts, and then having the proper spaces around those components. Now, one of the reasons when you talk about spaces is electricity, if you don't have enough spaces, will jump. If you get into a voltage that might be require 1-inch spacings, and if you only have a 1/2-inch spacing, you potentially could have a fault occur, and that's why the spacings become important. Again, just more showing an installation in a commercial building where you might have connection into your power distribution system. Also within Article 706, you have the ability to have a standalone system. So if you're out in the middle of nowhere, right, and you have an energy storage system, and in this case, it's probably going to be something other than just a battery system, right? But if you happen to be on a structure or building with an energy storage system that's not connected to a utility service source and is standalone. Another way you would consider a standalone is if you had a PV source, a PV system, and a battery energy storage system, or if you had a generator, if you were operating just off a generator, and you had an energy storage system that would be able to work in conjunction with a generator. So you would have power when you had to refuel the generator. Basically, you're talking about, when you talk about standalone systems, it's something that doesn't have any utility connection. And since we are talking about providing electricity to different parts of a building or residence or some other system, you need to make sure that it has overcurrent protection. And so in 706, it details where and how you do that protection with fuses or breakers or whatever type of device you're talking about. And then so you have the type of circuits and equipments. It shall be protected in accordance with Article 240. So for those of you that may not be familiar with the National Electric Code, the National Electric Code has got 8 main chapters. Chapters 1 through 4 are kind of the base requirements for electrical installations, and then chapters 5 through 7 provide modifications to one or replace sections of 1 through 4. So what you will see a lot in, and then the chapter 8 is for telecommunications, and it stands on its own. But in, say, in this case, for Article 706 in Chapter 7, you may see, instead of a replacement for Article 240, which is Overcurrent Protection, it sends you to that article and says you have to follow it, more as a reminder than a requirement, because Article 240 is part of the base requirements for electrical installations. If you go to B, where you're talking about overcurrent device ampere ratings, it just says the overcurrent protected device where required shall be rated again in accordance with Article 240, and rated provided on the system serving the energy storage system shall not be less than 125%. Again, what we're seeing with all these requirements is making sure that you have a safe installation, it's properly protected, and again, trying to prevent situations where you're going to have fire, right? Where we see what we saw in the first couple slides. So there are some other codes and standards. So that kind of covers the installation of energy storage systems. So Article 706 within the National Electric Code is where you go if you're going to work on an installation. If for some reason you're in a state that doesn't have that requirement, I would still go to the most recent published National Electric Code, which is the 2020 version, and utilize Chapter 706 from 2020. That would be, because if you happen to be one of the states that's under 2014 or 2011, there's nothing in the code that gives you that information. So the best way to approach that would be then go to the most current standard or code that has that requirement in it. And I would recommend at that point moving to just getting a copy of the 2020 NEC and working with that. So again, we talked a little bit earlier about NRTLs and UL being one of those. And we talked about I showed you the kind of the picture of the energy storage systems and equipment listing for UL 9540, but there are some other codes and standards that do affect some of the energy or ESS codes and standards. You have UL 1973 for batteries that might be used in stationary vehicle auxiliary power or light electric rail applications. Of course, the energy storage systems, UL 9548, which is a test method for evaluating thermal runaway fire propagation and battery energy storage systems. One of the things that was being looked at for the Arizona fire was that you had a fire propagation based on thermal runaway. And so this is a test method that allows for making sure the energy storage system is properly evaluated for safety. And then you have UL 1974, which is evaluation for repurposing of batteries. Lots of, if you're looking at, as we see, lithium-ion batteries, lead acid, NiCad, this standard covers what do you do when when your batteries are such that they can't provide energy storage. They use this a lot too with batteries that are used in hybrid and electric vehicles to if they want to try to do something with those batteries separate from once they can no longer be used in vehicles. Then there are also codes and standards, in the building code arena, right? So if you're going to be connecting energy storage systems to buildings, whether they're commercial buildings, institutional buildings, they're all built under various, either some part of the International Building Code or International Residential Code. And so within those, there's fire codes, as well as other types of installations that have to be followed. There's a big move within all of the fire codes to cover energy storage systems, after viewing what happened with the first responders on the Arizona fire. The other big standard for that's looking at energy storage systems is the International Fire Code. So if you go and look at some history here, you'll find that from 2000 to 2015, the primary focus of the International Fire Code was focused on traditional batteries and battery installations. Starting in 2018, there was a new chapter added, chapter 12, specifically on energy storage systems. And that covers also emergency and standby power systems, solar photovoltaic power systems, stationary fuel cells power systems, and electrical energy storage systems. So again, you can, as we talked about, you're seeing a significant change from the 2015 fire codes, whether they're the International Fire Code and the International Residential Code or NFP1 fire code, which tends to be a lot of states adopt NFP1 as their state law. And so you'll see a lot of movement here around energy storage across all of these standards. We talk a little bit about what the we've talked a little bit about installation standards and the requirements to for protection around the fire codes and the other building codes that talk about what you have to do if you're using energy storage systems. So we've talked about how to safely install per the National Electric Code. We've talked we saw the standards for building a safe energy storage system. What if you're going to install one, what you might need to do, the standards to go look at for fire protection in those areas. And now you have actually performance standards that are being revised. So you have future codes and standards impact. So there was an NFPA, a new NFPA standard, 855, that was published in September of last year, and that is the performance. It's a standard for the performance of energy storage systems, and it is it could be it's a standard that could be referenced by other NFPA standards. It could also be referenced by other building standards. And we're seeing actually some jurisdictions have adopted as a standalone document. So if you happen to be in an area that has a lot of energy storage systems being installed or looked at installations right now, then they're heavily involved in watching and keep an eye on NFPA 855. So this is the original publication. It is already in review and public comment for the next version to try to improve what was originally published. Then you also have revisions to the two UL standards, UL 9540 and 9540A. So those are also being looked at and revised to help improve safety. We've talked a little bit more about the fire codes, but the actual 2021 fire codes moving from 2018 are looking to align with some of the requirements within the NFPA 55. And then, of course, I mentioned the 2020 National Electric Code. That was a consolidation of requirements and an elimination of duplication in Articles 480 and 706, creating the better differential and line between just batteries and battery installations and actually energy storage systems, which even if they use batteries, it is part of a system, not just the batteries themselves.
Okay, we do have a couple of questions.
Okay.
We do have one says, do you have a slide for any of the Canadian standards related to energy storage?
So I do not have any slides for the Canadian standards, and I would need to go and see what they're looking at. I would venture to say it's probably going to be similar to from a CSA perspective. You could view, I don't know what the CE code is looking at, and I don't know what their fire codes are doing. That's something I haven't been involved in. We can take that as a to do and then communicate it back through Sharon, or if you want to, Sharon's going to give you my contact information at the end of the presentation. If you want to ask me that question directly, I'll contact some folks in Canada and try to get an answer for you. That might be the better way to do that.
Thank you. Let me see, we do have a couple of other questions, so if this is a good time, I'll ask you just a couple more. Let's see. Does the low voltage energy storage system from Schneider Electric is it equipped with harmonics conditioners?
So when you get into the actual construction, so UL doesn't require harmonic conditioning of a specific product. That's going to fall into, you know, if that's something that needs to be part of the building or part of the system design, that would need to be handled as part of that discussion. To my knowledge, I don't know necessarily of any energy storage systems that have power conditioning, other than when you start looking at having an inverter on the front end so you have AC coming straight off of it. Some of the different inverters can do power conditioning as well, versus you know, harmonics, but you're still doing the power conditioning. That'll clean some of the harmonics as well. So I don't know if that was a specific enough answer, but it's gonna again, that's gonna vary by design.
Okay, the next question is, how can we achieve savings from an energy storage system if the electricity fees rates don't change between day and night?
Well, now we're talking about you know, how how rates are made or set, and you know, I wouldn't even venture to guess that. That varies so much by states, right? I happen to live in an area where electricity is extremely cheap. Other people live in areas where it's extremely expensive. So it's going to vary and depend on, you know, what your state regulations are as it relates to cost, and also in some cases utilities. So I'll give you a kind of a little example here in Kentucky. We actually, so Kentucky's a regulated state, but we also have 122 different utilities that operate, electrical utilities that operate within the state. I know other states that have one. So, so when you start getting into time of day rates and things like that, it's going to vary a lot by state. It's going to vary a lot by jurisdiction. It's going to vary a lot by whether you're in a regulated or unregulated area. So other than that, other than telling you you're true, it's right, and it would be it's a kind of a confusing topic when you start trying to evaluate electricity rates. So.
Okay, I'm going to ask just one more for now, and then we'll move on with the presentation.
Right.
Does the energy storage system come with power factor correction banks?
So the energy storage system does not come with power correction. It is strictly an energy storage system. If you want to include power factor correction, whether it's standard power factor correction, you know, an harmonic filtered power factor correction, or even a solid state using solid state filtering, that would be separate from energy storage. It's not, again, that would fall into a system design, but that's not what energy storage systems do.
Thank you. All
right. So just to talk a little bit, this is just to kind of give you an overview organization of what the NFPA 855's standard on the installation of stationary energy storage systems is going to provide. Talks in general, the easy thing here is the design and construction and installation of all ESS and related equipment shall comply with Chapter 4 and as supplemented or modified by the technology provisions in Chapters 9 through 16. And what that talks about is, when we get into the other chapters, is the specific technologies for energy storage. As we talked about earlier, you know, a lot of discussion tends to be around the lithium-ion solution, because that's we'll call that the hot topic for energy storage. but there are other systems, and those have to be addressed as well, and are addressed in this standard. And then of course it talks about the systems interconnections, commissioning, operation and maintenance, and decommissioning. One of the issues if you're dealing with batteries is the decommissioning side. What do you do once you have your batteries are done? You have operation and maintenance. This is really important in when you're starting to talk about, some energy storage systems are gonna, you set them in place, you turn them on, you're still gonna need to maintain the disconnects, make sure your connections don't loosen with heating and cooling over time if they're outside. You also need to make sure that if you're using something that has more of a mechanical operation that you deal with that. So it needs to have the proper maintenance. And then of course I'm kind of going backwards here, but I wanted to kind of do that to lead you to this. Making sure the proper commissioning is done when the system's installed is really important as well. Making sure that everything's checked, not just somebody came in, dropped the connections and walked away from it. You want to make sure that your interconnections it operates when it's supposed to come online, it's going to come online. When it's supposed to go offline, it goes offline. And then if you're doing batteries, making sure the charging methodologies work. So with that, do we have any other questions?
Yes, we do. Let me just check here. So, what's a typical efficiency, AC to DC and vice versa?
So if you're talking about, when you're talking about the efficiencies on the conversion from the AC from the DC batteries to an AC output, it's going to vary a little bit based on your type of inverter and the technology there. But what I can do for that questioner and for those that may be interested, Sharon, if you get me that data, I'll go pull the efficiency data off the inverters that I know about and do a response that way, versus me trying to pull the efficiency right off the top of my head, which I don't know.
Okay.
Okay.
Next question. Yep. What kind of lithium chemistry is used in the Schneider Electric's battery, for example, NMC, LFP?
All right. So we do not manufacture lithium-ion batteries, and as a general rule, we're usually kind of packaging in different different technologies based on what the requirements are of the customer. We're not doing a Tesla Powerwall or some of the other standard product. So we will use what the client would like us to use based on the application.
Okay, what are some typical lifespans of large storage batteries?
I don't think we know yet, to be honest. We have, when you start talking about, let's back up. That question has kind of two pieces. The first piece is, the battery, the life of a battery, right? Is that life, if you're using a battery for a stationary battery supplying control for utility substation or power generation station, that's one thing, right? If you're talking about a battery that's part of a energy storage system, it might be something else. It's going to depend heavily on cycling, right? So, if you find it's being used a lot, then your lifespan is going to be significantly reduced. If it's not being used a lot, because it's only being used in an emergency situation or to store, when you're looking at PV, if it's just being used at night, or is it being used only as in an emergency because your utility is operating most of the time. So I hate to bounce that one around a little bit, but there really isn't a good answer for that. It really depends on the application And once the application is installed, it depends on the usage. And that, because that usage, that charging, recharging, and things like that, even with lithium ion, is going to determine the length of the life of those cells.
Okay. In some cases of energy management in industrial systems, it is recommended to use energy storage systems. Do you recommend battery storage systems for that?
I think it's going to depend on location. It's going to depend on what's available to you. So, you know, when you start looking at, if you happen to be into you know, a data center or a large load requirement, you know, something on the mechanical side, like a flywheel type energy storage system, might be better than, you know, than a battery energy storage system. And then if you happen to be in an area where you can make use of hydro, I know one of the local distilleries in Kentucky is actually using, because of where they're located, they have a lot of the water that they use for the production is at elevated such that they can actually take advantage of it to do significant energy storage from a hydro perspective. So it's going to depend, you know, if it's a small application for residential or small applications, battery systems are probably better. But when you start looking at where you might be and what you have access to, it's going to be different, right? Some areas have good geothermal energy storage systems, and you know, so it may depend on the application as well, what you're actually trying to do with your energy storage system. So, you know, if you're looking at a utility, you know, grid stabilization, you know, out in the middle of nowhere, those huge energy storage farm, for lack of a better term. If we saw the picture earlier in the presentation where you had 4 or 5 of those huge, look like switchgear rooms out in the middle of nowhere, you know, on a fence being used for voltage stabilization. So, and those were actually in, you know, in areas where, you know, we wouldn't have access to some of the other technologies. So to answer the question is, you know, if it's a small application, batteries are probably definitely the way to go. If you're looking at anything larger, it's going to depend on what you need, the size of capacity you need, where you are physically in the country, and where you have access to some of the other technologies, and doing that initial work to determine what's the best solution is really part of doing a good design for you know, in this case, like what we're talking about are variations of microgrids. So you start looking at making sure you have a good microgrid design that would include the energy storage. Anything else, Sharon? Any more questions?
Yes, we've got several more, and I do apologize if we don't get to your questions because we probably will not get to all of these. The next question is, what is the largest capacity of an energy storage system?
I don't know. I mean, I've seen standalone systems as large as 2 megawatt, but I've also heard of systems that were significantly larger. What you end up doing in those cases is taking and running things in parallel in order to ramp that up. So, but I really don't have an answer for that.
Okay. Let's see. Based on the Arizona Public Service case study, what is the greatest risk with energy storage systems from, say, an FM global perspective?
So what's interesting with FM, it would be, I mean, it's obviously fire. That would, you know, and being able to be concerned with, you know, with making sure that the system was built appropriately, applied appropriately, installed appropriately. But the biggest thing for them is going to be, and it's going to depend a little bit on where it's installed, right? If you're talking about a standalone, if we refer to the case study from Arizona Public Service, we know that was a standalone system kind of out by itself, right? It didn't have the impact of anything around it. Where they're going to get, quite frankly, very nervous is what happens if you're putting an energy storage system in the basement of a building, right? Because you're in a more urban environment. I've got PV on the roof and I got the batteries in the basement, or something like, or a vault or whatever, right? Making sure that you have the proper, you have an energy storage system built to the proper standards, installed to the proper codes. That's going to have the proper fire suppression requirements. Those are part of that design. But I mean, that if I'm FM, the concern I have is when it's applied in things where it could be separated, where if that does create, if a fire is started or is created, more things are affected than just the unit itself. Now, I mean, there's no good fire. Don't get me wrong. I'm not saying there is, but that is an area that that they would probably need to be pay attention to. The key thing is making sure that these standards, all these standards are new and they're in development. I would also recommend that they be involved in participating in those committees to be part of that development and understand what's going on so they can have their input. Okay, Sharon.
Okay. Can we store energy from thunder and lightning?
Not that I've seen, but I mean, lightning's a heavy thing. Being able to control that is extremely difficult. It's not consistent, and in trying to manage that, I'm not sure how we would do that. Okay, another one. Sharon?
Sorry, I was muted. I read one.
Oh, okay.
Apologize. Can you speak to what guidance is available for the installation of energy storage systems on federal sites?
Yeah. So for federal sites, that they use the National Electric Code. In general, while they may not have to, they do. Usually, they usually follow the version of the National Electric Code of the state in which the site is located, and but in general, they tend to use they prefer to use more of the newer standards. So we see them. We see requirements for them when we're doing overseas activities, especially in the State Department, and you'll find some of the departments may operate a little differently. I mean, the federal government's a big place, right? So some will operate differently. Security drives some of it as well in some types of installations, but in general, they usually try to follow the local standards, because that's usually what the people that are coming in and doing the work know. But they'll also will use some of the newer standards if needed, or have like we were talking about, right? With 24, if you're in a state that says 2014, it doesn't have NEC doesn't have an installation standard for batteries or for energy storage systems. You'd have to go to 2017 or 2020. In those cases, you would see the government referencing the 2020. Then you also have, there's another totally different standard for utilities and the work on utility side, and that's the NESC, National Electric Safety Code. That tends to be the utility side. So the National Electric Code is from the meter on the end user side, and then the NESC is what is being used on the utility side, and they're using in general it's very similar wording and application. They just have a different scale.
Okay, so I think we're going to wrap up there. We do have a few more questions, and once again, I do apologize if we didn't get to your question. Keith, I will forward you the Q&A report, so you can go ahead and reach out to some of these folks if you're happy to do that. But also remember that I will be following up everyone with a follow-up email in the next couple of days, and you'll receive your link to your certificate of attendance for today, plus a link to the recording for today. And also included in there, if you do wish to request a copy of the presentation from Mr. Waters, his email address will be included in there also. So questions and requests for the presentation can go directly to Mr. Waters himself. Just a couple of closing announcements. First of all, thank you everyone for being with us today. I appreciate your time. And I particularly appreciate you, Mr. Waters, for giving us your time and expertise today. Our members and us all here at AEE appreciate that very much. We do just want to say that for those of you that were not aware, and I think pretty much everybody is at this time, but due to safety concerns in the current environment for our members, our speakers, our exhibitors, and our attendees, we have cancelled AEE East in Cincinnati next month. So we are looking to offer some additional online options for people that were interested in doing some more training, or who perhaps were planning on attending training at those events. We will continue to monitor the situation going forward. We do have AEE West scheduled in Seattle in June, and we hope that that will go ahead, but obviously we will monitor the situation till closer to the time and keep checking our website for updates. Please also check the website for updates on any live training event cancellations. We have had multiple live training event cancellations throughout the world, but we are, like I said, trying to offer more online training options for you guys. So please keep checking back to our website, our education website, to see what we have on offer for you. And the only other thing really is to say, our next member webinar is on Thursday, the 9th of April, with Marie Curatolo. Please join us for that. You will be receiving the email for our April webinars on probably Monday, but certainly early next week. We'll give you the registration and information for those. And please, everybody, stay well and stay safe. And we look forward to seeing you again on April 9th. Thank you, everyone.